It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
Mercury lives in a cosmic hot zone that holds important clues to the origins of our solar system.
Mercury has been among the most difficult planets in the solar system to study.
Mercury isn't just a dead, rocky planet near the sun. It's hiding secrets that no one, not even NASA, saw coming. And these secrets might change everything we thought we knew about Mercury. Now, after almost 50 years, NASA telescopes have found something so shocking that they'd rather keep it under wraps. What exactly did the James Webb Telescope find, and why does it matter so much? Mercury exploration history. Mercury, the smallest planet in our solar system, has always been a mystery for NASA. It sits closest to the sun, so it's often overshadowed, literally and figuratively, by its more famous neighbors, like Venus and Earth. You might think Mercury is just a dry, boring rock spinning endlessly around a giant fireball, but trust us, there's more to it than meets the eye. For starters, it's super tiny. If Earth were a basketball, Mercury would be roughly the size of a golf ball. Actually, a little bigger than our moon. It's this tiny but mighty character that makes Mercury so interesting. Now you might wonder, what's the big deal about Mercury being close to the sun? Well, its proximity to our blazing star means it experiences temperature extremes that could fry and then freeze anything. During the day, Mercury's surface can get up to a scorching 800 degrees Fahrenheit, 430 degrees Celsius. But at night, it can drop all the way down to minus 290 degrees Fahrenheit, 180 degrees Celsius, more than double that of Oymyakon, Siberia, which holds the official title of the coldest place on Earth. Can you imagine that? Now let's talk about Mercury's surface. This planet looks like our moon, all covered in craters and scars. That's because it doesn't have much of an atmosphere to protect it from rogue meteors. When those space rocks come crashing in, they leave their marks, which stay forever. These craters have even earned names like Beethoven and Shakespeare. It's almost like Mercury is a cosmic tribute to Earth's great artists. So when did we start learning about this mysterious little world? It wasn't until 1974, when NASA's Mariner 10 swung by, that we got our first real glimpse. Mariner 10 was a true pioneer, making not just one but 3 flybys of Mercury, a little planet that had never had visitors before. The spacecraft sent back over 2,800 photos and gave us our first real taste of just how cratered and rugged Mercury's surface really was. After Mariner 10, Mercury went quiet, at least for human exploration, for over 30 years. Then, in 2004, along came Messenger. By 2011, Messenger entered Mercury's orbit and began taking pictures, mapping out Mercury's surface like a detective solving an ancient mystery. And what did we learn? A lot. We discovered that Mercury had way more surprises, like a magnetic field, something no one expected from a planet so small and seemingly dead. Another shocker? Mercury is heavy, really heavy. It's got a massive iron core that takes up about 85% of its volume, way bigger, proportionally, than Earth's core. Scientists believe that this could be because Mercury lost a big part of itself in a cosmic hit and run, a theory that's got some people buzzing. Mercury is full of these oddities. Its orbit, for example, is an ellipse, so it's closer to the sun at some points and further at others. This means not only crazy temperature swings, but also strange sunrises and sunsets. At certain spots on Mercury, the sun can rise, pause, move backwards, and then keep going. Mercury may be tiny, but it's packed with strange characteristics. It's got everything from scorching heat to icy nights, giant cores, and peculiar orbits. So what does all this mean for the mysteries of its rotation and its day that's longer than a year? Well, let's get right into it. Why does Mercury's day make no sense at all? A year shorter than a day. Can you imagine a planet where a single day is actually longer than an entire year? Sounds confusing, right? Well, that's Mercury for you. Let's break this down. Mercury takes only 88 Earth days to make one complete lap around the sun. In comparison, it takes a whopping 176 Earth days for Mercury to spin around just once on its axis. Yep, that means that by the time Mercury completes one rotation, which we call a day, it's already traveled twice around the sun. That's why on Mercury, a year is half the length of a day. No wonder this tiny planet gets a reputation for being a little weird. But why does Mercury act this way? It all comes down to its rotation and the influence of the sun's massive gravitational pull. You see, Mercury is in what scientists call a two-spin orbit resonance. This means that Mercury completes 2 orbits around the sun for every 3 rotations on its axis. It's almost like Mercury and the sun are locked in some kind of cosmic tango, with Mercury always being pulled just a little off balance. This tug of war between the sun's gravity and Mercury's spin is why its rotation is so slow and its day outlasts its year. The gravitational pull has slowed Mercury's spin down over billions of years. This spin-orbit resonance also explains why the sun appears to do that weird back-and-forth trick in Mercury's sky. As the planet nears the closest part of its elliptical orbit to the sun, it speeds up slightly, enough that its rotation can't keep up. This causes the sun to appear as if it's moving backwards for a short time before continuing on its way. It's like Mercury's rotation and orbit get a little out of sync, and the sun moonwalks across the sky for a moment. What's even wilder is how all these unique movements create some of the most extreme conditions in our solar system. Because of its slow rotation, one side of Mercury bakes in the sun for months, while the other stays in the dark, freezing cold. It's no wonder Mercury is known for its incredible temperature swings. It's like one half is a desert at high noon, while the other half is Antarctica at midnight. The day-night cycle is unlike anything we experience on Earth. There's no gentle transition from day to night, just a brutally long, scorching day followed by an endless, icy night. Mercury's unique spin and orbit don't just make for interesting facts, they also leave scientists scratching their heads. Understanding how Mercury got into this strange pattern helps researchers learn more about the forces at play in the early solar system. Was Mercury always like this? Or did something happen to slow it down and throw it into such an odd spin? These questions are still being debated, with new theories and models trying to explain how Mercury ended up the way it is today. Mercury's odd rhythms make it a world of extremes: strange orbits, long days, and intense heat and cold. But this is just one part of the puzzle. What other shocking discoveries can we find when digging deeper into Mercury's core and magnetic field? Mercury's hit and run past. Billions of years ago, the early solar system was a wild place. It wasn't all peaceful orbits and twinkling stars. Instead, it was more like a cosmic collision. Planets were forming, smashing into each other, and trying to stake their claim around the sun. Mercury might have gotten the short end of the stick among these chaotic happenings. Scientists think that Mercury was involved in a colossal collision at some point in its youth, and this was a full-on planetary smash. This theory, known as the hit and run collision theory, suggests that Mercury didn't start off as the small, dense planet we see today. Instead, it might have been much more significant, with a thick mantle and a lot more mass. But then, out of nowhere, another large object slammed into it. This intense impact stripped Mercury of its outer layers, leaving behind a thin shell and a massive iron core. That's why Mercury has an oversized core that makes up roughly 85% of its volume compared to Earth, whose core is only about 15% of its overall size. It's almost like Mercury is wearing a tiny rock jacket over a vast iron heart. This leftover core makes Mercury so heavy compared to its size, almost like a solid metal ball pretending to be a planet. The idea of this giant collision isn't just wild imagination. Scientists have evidence to back it up. When NASA's Messenger spacecraft started investigating Mercury in detail, it found that the planet was unusually dense. It also spotted some abnormalities in the composition of Mercury's surface, like a lack of lighter elements that would typically be there if Mercury had its full outer layers intact. Imagine peeling an orange and being left with just a tiny bit of the peel and mostly the juicy core. That's Mercury after its unfortunate cosmic accident. This theory paints a picture of the early solar system as a pretty rough neighborhood. Planets and protoplanets were crashing into each other like teenagers at a bumper car rink, and only the strongest or luckiest survived. And in this case, Mercury wasn't so lucky. It's kind of amazing to think about. This little planet, which seems so quiet and unassuming now, has this wild and dramatic backstory involving giant cosmic collisions and incredible violence. The aftermath of that collision changed everything for Mercury. It lost a lot of its outer material, but it kept its hefty iron core. And that core, as we previously stated, is a big reason why Mercury has a magnetic field, even though it's such a small planet. Most planets Mercury's size don't bother with magnetic fields, but Mercury, it still hangs on to one. The core stayed molten enough to generate this magnetic field, which is pretty rare and impressive for a planet that seems so tiny and lifeless from the outside. So was it just one impact that changed Mercury, or could it have been more? Some scientists argue that there may have been multiple impacts. Maybe Mercury had a few unlucky days thousands of years ago. Whatever the case, it's clear that Mercury went through a lot to become the planet we see today. All those scars on its surface aren't just from meteors. They tell the story of a planet that's been battered, bruised, and stripped down to its very core. Mercury's giant core mystery is just one piece of its puzzling history. But what about the aftermath of that huge collision? How does it tie into Mercury's strange magnetic field and the extreme conditions we see on its surface today? Extreme temperatures in the fleeting exosphere. If you think your local weather is unpredictable, Mercury's temperature swing will make any earthly heat wave or cold snap look like a gentle breeze. With no real atmosphere, Mercury has nothing to help regulate its temperature. The reason for these wild swings is that Mercury doesn't have what we'd call a proper atmosphere. On Earth, we have air that traps heat and spreads it around, keeping things relatively comfy. Mercury, on the other hand, is a minimalist. It lacks that cozy layer, so when the sun hits it, there's nothing to hold in the heat. It's like turning on a blowtorch and then immediately pointing it elsewhere. And when night falls, all that heat just radiates away into space, leaving the surface freezing cold. It's the ultimate hot and cold relationship. Instead of a thick atmosphere, Mercury has something called an exosphere. Honestly, calling it an atmosphere would give it too much credit. The exosphere is more like a thin, fleeting mist of particles, barely hanging around the planet. It's made up of atoms that are knocked off Mercury's surface by the solar wind and micrometeorites. The particles that make up this exosphere include things like hydrogen, helium, and oxygen. But the shocking part? There's even a bit of water vapor. Yes, water, on a planet that's so close to the sun you'd think it would evaporate instantly. It turns out that when the solar wind hits Mercury's surface, it can cause a reaction with oxygen in the rocks, creating small amounts of water vapor. It's not like there are lakes or anything, far from it. But the presence of water vapor is one of those little surprises that make Mercury so fascinating. Scientists first discovered this water vapor during the Messenger mission, which orbited Mercury from 2011 to 2015. Messenger was like a detective, sniffing around and taking samples of everything Mercury offered. The water vapor was unexpected because Mercury is, in every sense of the word, a scorched planet. And yet, even in such harsh conditions, there are hints of water. It's kind of like finding a snowball in the middle of the Sahara. So how does Mercury hold on to this exosphere if it's constantly losing particles? Well, the truth is, it doesn't. The exosphere is continually being replenished. Solar wind, micrometeorite impacts, and even the radioactive decay of Mercury's crust all contribute to keeping this fragile layer around. It's a constant cycle of being lost to space and replaced. But what does all this mean for Mercury's surface and the environment? The lack of a proper atmosphere means no protection from the sun's harsh rays or incoming space debris. That's why Mercury is riddled with craters and looks like it's been through several rounds in the ring. There's no erosion, no wind to smooth things out, just impact after impact, and it's all perfectly preserved. It's almost like Mercury is a time capsule, holding on to every scar from its past. Mercury's extreme temperatures and its flimsy exosphere make it one of the most hostile places in our solar system. But despite its harsh environment, it has managed to surprise us again and again, whether it's the presence of water vapor or the way it is so close to the sun without breaking apart. So what else could Mercury hide under its scorched and cratered surface? Could more secrets be hiding inside its oversized core or a mysterious magnetic field? Water, ice, and organics. All right, it's time to reveal the most surprising discoveries about Mercury. Water ice. Yep, you heard that right. Scientists found water ice on a planet where daytime temperatures could easily fry your breakfast eggs and nighttime temperatures could freeze them solid again. The trick here is that the ice hides in Mercury's permanently shadowed craters, tucked away near its poles. These areas are like nature's refrigerators, never seeing the light of the sun, staying icy cold, and preserving water for millions, maybe even billions of years.
The ice is contained in places where literally the sun never shines.
You see, Mercury's poles are home to craters so deep that sunlight never reaches the bottom. Because of this, temperatures in these cold traps can stay at a frigid minus 290 degrees Fahrenheit, 180 degrees Celsius, even while the sun scorches the rest of the planet. Think of it like those dark corners of your freezer where you forget a tub of ice cream. It stays perfectly frozen and hidden from view. These shadowed regions have essentially been frozen since the dawn of the solar system, making them perfect for preserving water ice. So how did the water ice get there in the first place? Well, scientists think it might have arrived via comets or asteroids that smashed into Mercury ages ago. These space rocks, carrying water and other compounds, could have delivered enough material to fill those cold traps. Another possibility is that solar wind interactions with Mercury's surface somehow created water, which migrated to dark spots permanently. It's like Mercury managed to hold on to a little treasure from the cosmos amidst all its struggles with heat and space rocks. But it gets even more interesting. Alongside the water ice, scientists have also detected something else: organic compounds. These are carbon-based molecules, and while we're not talking about aliens or thriving bacteria, organic materials are one of the essential building blocks for life. These compounds could have also come from comets, which are known to carry complex molecules. It raises the question, could the conditions in these cold, dark craters have been or still be suitable for some form of simple life? Now let's talk about extremophiles. These tiny organisms grow in conditions that kill most other life forms, like boiling hot springs, deep-sea vents, or Arctic ice. On Earth, extremophiles have been found in places where temperatures swing wildly or where there's almost no sunlight. If they can survive in those environments here, who's to say something similar couldn't survive in Mercury's polar craters? It's a wild idea, but the thought that life, even just microbial life, might exist on a planet so harsh makes Mercury a lot more interesting. The discovery of water, ice, and organic compounds has completely changed how we think about Mercury. For so long, we assumed it was a dead, dry world with nothing to offer but heat and craters. However, these findings suggest that there might be more to the story. If these cold traps have held onto water and organics for billions of years, they could keep secrets about the early solar system. It's like a time capsule, preserving clues about where we came from and how the building blocks of life could spread across planets. And this is just scratching the surface. We still don't know exactly how much ice is there, but one thing is clear. Despite its extremes, Mercury keeps finding ways to surprise us. Could other secrets be hiding in these dark craters? Could those building blocks of life tell us more about how life could form elsewhere in our solar system? The magnetic field mystery. Mercury is full of surprises, and its magnetic field is another big one. When NASA's Messenger spacecraft first detected it, scientists were stunned. Not only did Mercury have a magnetic field, but it was also unlike any other in our solar system. It's weak, sure, but it's there, hanging on stubbornly like Mercury. Mercury's magnetic field is even more intriguing because it's not centered like Earth's. Instead, it's offset by about 20% of Mercury's radius to the north. Imagine holding a magnet, but instead of the center of the magnetic field being in the middle, it's closer to one end. This means that Mercury's northern hemisphere gets more magnetic shielding, while the southern side gets the short end of the stick. This strange asymmetry has made scientists scratch their heads and wonder just what's going on beneath Mercury's surface. Now, Earth's magnetic field is pretty straightforward. We have a solid inner core surrounded by a liquid outer core made of molten iron. The movement of this liquid iron generates Earth's magnetic field, like a giant dynamo. Mercury, though, plays by its own rules. It also has a molten core, but scientists think that only a thin layer of it is churning and active enough to create a magnetic field. That thin dynamic layer seems to be enough to generate a field, but because it's so different from Earth's setup, the magnetic field ends up lopsided and, well, a bit odd. The fact that Mercury even has a molten core is interesting in itself. Given its small size, scientists expected that Mercury's core would have cooled and solidified long ago. However, the offset magnetic field suggests that part of it remains liquid, still moving around and generating magnetic activity. And because the magnetic field is offset, it tells us that the internal structure of Mercury is likely anything but typical. There might be variations in the thickness of its crust or other strange internal dynamics that we're still trying to understand. This offset magnetic field also means that the effects of solar wind on Mercury are unique. The solar wind, which is a stream of charged particles coming from the sun, interacts with Mercury's magnetic field in ways that are different from what we see on Earth. With less magnetic coverage on the southern side of Mercury, the solar wind can get much closer to the surface, almost directly hitting the planet. Mercury's southern hemisphere is constantly peppered by solar radiation, while the northern half has a little more protection. Scientists are still trying to figure out why Mercury's magnetic field is so weird. One idea is that Mercury's molten core isn't evenly distributed, leading to that lopsided magnetic field. Another thought is that the intense gravitational pull from the sun has shaped how Mercury's core moves and behaves. It's all part of the mystery, and every time we think we're getting closer to an answer, more questions appear. So what does this tell us about Mercury's overall structure? If its magnetic field is offset, something deep inside Mercury is pulling strings unexpectedly. Understanding this might help us learn more about Mercury and how magnetic fields can form and evolve on other planets, even beyond our solar system. It's all about putting the pieces together to figure out the bigger picture of planetary evolution. Mercury's magnetic mysteries are just one part of its incredible story, but there's still more to uncover about this stubborn little planet. What else could we learn from its surface and its oversized core? Could there be more hidden surprises beneath that scorched crust? Let's keep going and see what other secrets Mercury has been hiding all these years. Traces of a fiery past. If you think Mercury's current state is extreme, you should hear about its wild past. Mercury wasn't always the small, seemingly lifeless rock it is today. Scientists believe that in its youth, Mercury was a lot more active. Evidence suggests that beneath Mercury's surface once lay a massive magma ocean. This ocean wasn't something you'd want to dip your toes in. It was molten rock bubbling and boiling, covering a large part of the planet. But how do we know that Mercury was once so volcanically active? Well, NASA's Messenger mission uncovered some fascinating clues. When the spacecraft orbited Mercury, it found that huge portions of the planet's surface were covered in vast volcanic plains. These plains are massive, smooth areas that look like they were created by rivers of flowing lava. The lava solidified and left behind what now appears to be a smooth, expansive area. Imagine molten rock pouring out, spreading across the surface, and then freezing in time. That's what these plains are. Then there are the volcanic hollows, which make Mercury even more of a mystery. Hollows are these strange, shallow depressions scattered across the planet's surface. Scientists think they formed because of sublimation, the process where something goes straight from a solid to a gas. In Mercury's case, volatile elements like sulfur in the crust were heated and disappeared into space, leaving behind these sunken spots. It's like Mercury had pockets of material that just decided to pack up and leave. Poof, no trace was left behind except a hole. The hollows give Mercury this eerie, almost Swiss cheese-like texture in some areas. Another clue about Mercury's fiery past is its many craters, some partially filled with solidified lava. You can almost picture it. An asteroid slams into the surface, and molten rock from beneath oozes out, filling in part of the crater. The craters tell stories of impact events and the molten sea that flowed beneath the crust, ready to burst forth when given the opportunity. It portrays a picture of a planet that wasn't just sitting quietly near the sun, it was full of action, with molten rock pouring across its surface, reshaping itself repeatedly. The idea of an ancient magma ocean suggests that Mercury's early years were even more chaotic. Just think, millions or billions of years ago, this tiny planet was like a giant pot, with magma sloshing around under its thin crust. It's thought that as Mercury cooled, this magma ocean eventually solidified, creating the surface that we see today. But in some spots where the crust was thinner or weaker, the magma found its way to the surface, leading to the vast plains we observe now. This geological activity has long since cooled down. Mercury today isn't spewing lava or having volcanic eruptions, but those scars, those smooth plains, and strange hollows are remnants of a world that once had much more going on beneath the surface. These volcanic features have helped scientists piece together the planet's dramatic history, giving clues about what might have happened in the early solar system when everything was still settling. So what does all this tell us about Mercury? For one, it's a planet that's undergone many transformations. It wasn't always the quiet, cratered surface we see now. Instead, it was a place of fire, with molten rock reshaping its surface repeatedly. This transformation makes Mercury an excellent example of how dynamic planets can be, especially in their early stages. The volcanic plains and hollows are like a snapshot of when Mercury was alive with heat and movement. The evidence of Mercury's fiery past gives us another reason to marvel at this little planet's strength. But with all this volcanic activity and changes, what other surprises still hide beneath Mercury's surface? Could more secrets be waiting in the core? Or more about its magnetic field that ties into this story? Let's look closer and discover just how deep Mercury's mysteries go. Bepi Columbo and the future of Mercury exploration. So what comes next for Mercury, the little planet with all those big secrets? Well, that's where the Bepi Columbo mission comes in. Bepi Colombo is a joint effort by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. This spacecraft was launched back in October 2018, and its mission is to explore Mercury in more detail than ever before. But getting to Mercury is no simple task. Bepi Colombo's journey to Mercury is a long one. The spacecraft must do 9 flybys of different planets, Earth, Venus, and Mercury, before it can finally settle into orbit around Mercury in 2025. These flybys are all about using gravity to slow the spacecraft down enough to eventually enter Mercury's orbit. The sun's massive gravitational pull makes it challenging to get anywhere near Mercury without zooming past it at an uncontrollable speed. It's like trying to park a race car going full throttle. Bepi Colombo has to take its time and ease its way in. One of the most incredible things about Bepi Colombo is that it's made up of 2 different orbiters. There's the Mercury Planetary Orbiter, built by ESA, and the Mercury Magnetospheric Orbiter, built by JAXA. The 2 orbiters are traveling together to Mercury, each with its own job once they get there. The Planetary Orbiter will focus on mapping the surface and studying the geology, while the Magnetospheric Orbiter will explore Mercury's magnetic field. Together, they are like a tag team, ready to reveal the mysteries that have puzzled scientists for decades. Bepi Colombo will face some severe challenges once it arrives at Mercury. For one, the temperatures are extreme, reaching as high as 450 degrees Celsius, over 840 degrees Fahrenheit. To handle this, the spacecraft is equipped with special insulation to protect it from getting roasted by the sun. The orbiters have to deal with not just the heat, but also intense radiation from the sun. It's like going to the hottest desert in the world, except you're also being hit with powerful solar rays. To make matters even tougher, Bepi Colombo needs to keep enough power to operate while constantly switching between burning hot and freezing cold areas as it moves around the planet. But why did all this effort go into exploring Mercury? Because there are still so many questions that need answering. Scientists want to know more about Mercury's oversized core, how it formed and what it's made of. They also want to get to the bottom of that weird, offset magnetic field. And of course, there's the mystery of those shadowed craters filled with ice. Bepi Colombo has the tools to measure the magnetic field up close, map out the surface in unprecedented detail, and help us understand what makes Mercury tick. Studying Mercury can also teach us a lot about the history of our entire solar system. Since it's the closest planet to the sun, it experienced intense experiences that might be very different from those of other planets. Understanding Mercury's history might help us understand how rocky planets like Earth formed and evolved. It's like Mercury is a fossil of the early solar system, holding secrets about how things looked billions of years ago. The excitement doesn't stop at just science, though. Bepi Colombo's mission is also a story of incredible engineering. The fact that humans have designed a spacecraft to travel such a complicated route, withstand such harsh conditions, and reveal things we've never known before is nothing short of amazing. It's proof of our continuous curiosity and our determination to explore every corner of our solar neighborhood. So what will Bepi Colombo find once it gets there? Will it solve the mysteries of Mercury's strange magnetic field? Could it discover something completely unexpected hiding in those shadowed craters? We'll have to wait just a little longer, but one thing is for sure. Mercury's story is far from over, and we might just be on the edge of uncovering its greatest secrets yet. Mercury may be small, but it's clearly full of surprises. With all these secrets coming to light, could there be even more shocking discoveries waiting in our solar system? What hidden worlds or untold mysteries do you think we'll uncover next? If you enjoyed this video, don't forget to like, comment, and subscribe. Your thoughts and theories could be featured in our next episode. Let's keep the conversation going.